Hello everyone, welcome back. This video will learn how we can control DC motor with Arduino. So let's get started. As mentioned earlier in previous lessons, we know DC motor control, they concern about two types of control. The first one is direction control. We can run the DC motor in both direction. And the second one is speed control. By using PWM pulse, we can control the speed of the motor shaft. So these two things we'll learn in this video. We also learned that we cannot connect DC motor directly to the Arduino output pins because the current rating of the Arduino output pins, these are limited to 20 to 40 milliamps, whereas a small size DC motor, they can drive up to 100 milliamps to 1 ampere for small applications. It can exceed these limits also. So that's why it's not safe to directly connect the DC motor with the Arduino board. We use motor driver in between these two devices to act as an interface. So this motor driver, this connect an external power supply with the DC motor and receives the signal from the Arduino Uno. So now let's have some idea about this motor driver. So there are basically two types of popular motor driver available on the market. The first one is L293D model and the next one is L298N dual motor driver IC. So the first one is, it's a dual H-bridge motor driver IC and the second one is dual motor driver IC. Both serves the similar purpose, but there are some difference between them. Let's see from the table. So H-bridge configuration, the first one is dual H-bridge and the second is dual full bridge. Current rating, the first one, this involves current rating around 600 milliampere per channel, and this second IC, it can handle up to 2 ampere per channel, and obviously there is a heatsink for that. Voltage rating, it can handle up to 36 volt, whereas the second one, it handles up to 46 volt. In first IC, there is a built-in diode, but in the second IC, there is no built-in diode and external diodes are required. Complexity, the first one is easier to use, whereas the second one is a little bit more complex. About the controllability, both of them, they can handle 2 DC motor at a time or 1 stepper motor. So from the discussion, we can say that for a small application and for a small amperage, we can use this L293D model. But if you're looking for a larger motor for your project, you should go for this one, L298N. Now, we have been using Okui platform for our previous simulations. Okui does not include the motor driver IC at their library for simulation. For this purpose, we will use Tinkercad. So Tinkercad has this L293D model IC at their library, and we will demonstrate how we can use this IC in our Tinkercad platform. This IC, you can use it separately with a IC at your PCB circuit, or it comes with modules like this one. So here you can see it's a complete package with this IC inserted in the module. You can also use this sort of module. So we'll learn the basic one. We'll learn how we can interface this IC directly at our project. The process is similar if you're looking for the module. Well, let's talk about this pin out of L293D IC. The first pin, that is the VCC1, this is the supply pin for this IC. So this power is required to run this IC. Here we can connect 5 volt supply from Arduino. And here are 4 ground pins. You need to connect the ground pins of the Arduino to any of this ground pin and connect them together. The second source is the motor power supply. This is an external power supply required for motor, and this power supply power will be redirected to the motor. You need to connect the ground of this motor power supply to the Arduino ground. That means all the grounds should be connected together. Now comes the motor itself. To drive a motor, we need 2 terminals, and L293D IC provides output 1 and output 2 for first motor. And these are from 3 and 6 number pin of the IC. If your project has second motor, you can connect that also with output 3 and output 4 from 11 number pin and 14 number pin. So these are output pins for motor. Now let's say you want to control this motor. I'll show for the motor 1. The same goes for motor 2 also. To control the motor 1, you need to give command from the Arduino to this IC. The first command is about direction. This input 1 and input 2, this command should come from Arduino digital pin. And according to the signal supplied from the Arduino, the motor will rotate in clockwise or in anti-clockwise direction. According to the signal provided to this pin, input 1 and input 2, the motor direction will be controlled. Now let's say you want to run this motor at full speed, or you want to change the speed of this motor. That will be controlled from this enable 1 2 pin. That is the first pin of the IC. So you can supply 5 volt directly to this pin. It will enable the motor to run at full speed. Or if you want to run the motor at variable speed, then you can supply PWM pulse at this pin. So that's all the control for the first motor. Similarly, for second motor, we have input 3 and input 4 to control the direction, and enable 3 4 pin, that is the 9 number pin, to control the speed of the motor. I hope you got the idea about the pin out of this IC. So let's jump out to the Tinkercad and let's see how we can build the circuit at there. We'll come to tinkercad.com. This is the platform. We have already published video on this. So after coming here, we'll log in at the website. If you're trying this website for the first time, you should go for the sign up option. Let's log in here. I'm an educator, so I will choose this one. You can use any of the provided option for sign up. So after signing in, the platform should give a dashboard like this one. From here, we'll go for design on the left hand panel. And after coming here, press this create button. From the list, you should choose this circuit. This will bring up the dashboard for circuit building. Here, we will first bring in the Arduino Uno. So Arduino, they are providing two types of Arduino here, Arduino Uno and ATTini. So we'll bring in the Arduino Uno. Let's rotate this Arduino Uno to make some space here. Now we need motor and motor driver. Can search here for motor, and this will bring all the components related to motor at Tinkercad library. We'll first bring in a DC motor. And the motor driver, there are two types of component related to motor driver here. The first one is H-bridge motor driver, and they have another motor driver, Polo Loose simple motor controller. So this has enabled RC features on this module. For now, we'll take this L29 3D IC. Let's rotate this also. Okay, so already we have learned about the pin out of this IC. Let's connect them quickly. First of all, the VCC for this IC, that is here, we'll take wire and connect it to 5 volt of Arduino Uno. Let's make it red color. Then we have ground. Let's make a short for all the ground first. Now, from here, we'll bring in a ground terminal for this pin. Okay, so let's make all the ground black color. Also, you can make a quick connection for this pin. So now all the grounds are connected. We have another external power supply that we need for our DC motor. So let's bring in a power supply, DC battery, or you can say simply battery. So they have three types of battery here. The first one is the 9 volt, then they have 3 volt coin battery and 1.5 volt battery. So let's bring in the 9 volt battery here. We can also make a rotation. Okay, so we need to connect this positive terminal of the battery to the VCC2, that is the power 2. Let's make this to red color to understand it better. And we have another negative terminal. As all the grounds are connected together, we can simply connect it here. So let's make it black. Now our DC power supply is connected with the L29 3D IC as well as the Arduino power supply at the VCC1 and the ground. all the grounds should be connected together. You should remember that. Now the motor, we can connect two motor at a time with the L293D IC. The first motor terminal, we have output 1 and output 2 here. So this output 1, this should go for the first terminal of motor, and this should go for output 2. Okay, so let's make it red color. Okay, so now our motor is also connected with the output terminal of the IC. The last step is to connect the input pins from the Arduino to L293D. We have input 1 and input 2 for direction control. So let's connect them together. Let's connect input 1 to pin number 8, input 2 to pin number 9, and enable pin. Remember, if you want to control the speed of the DC motor, you must connect this enable pin to a PWM enable pin of Arduino. So that's why I have connected it to pin number 10. Similarly, you can connect another motor to this IC using this output 3, output 4 terminal, and this input 3, input 4, and enable 3, 4 pin. These pins are allocated for second motor. To keep it simple, we'll just see one motor demonstration for this video. The circuit connection is complete. I hope you got the idea. Already you have explained which pin to connect where at the presentation slide. Now let's make the program for a motor. To program for any of the project simulation, you should come up here and press this code button. They are providing 3 types of method, like you can simply drag and drop using blocks. You can make a combination of block and text together, or you can simply go for text. So as we are working for text from the very beginning, we'll choose this one. Now let's delete this code and write our code for this project. At the beginning of the program, let's define the pin for our program associated with motor control. The first pin is input 1, which is connected to 8 number pin of Arduino. Then we have input 2 connected with 9 number pin of Arduino, and enable pin that is connected to 10 number pin of Arduino. Let's define them one by one. Constant int. So that's all for the definition. In the void setup, we need to define which pin is input and which pin is output. For Arduino, we are using only 3 output pins, and these pins are 8, 9, and 10. For that reason, we will use pin mode. So all these 3 pin, input 1 pin, input 2 pin, and enable pin, all these pins will be used as output for our project. Now let's do the program for direction control. First, we will move the motor at a clockwise direction. Then after a pause, it will move in an anti-clockwise direction. So let's see how we can do that. So first we will go for clockwise rotation, then also add a block of, we want to stop the motor. So let's write the comment here, stop motor. For direction control, we'll first use digital write. Digital write input 1 pin. Remember, for controlling the direction, input 1 and input 2 is used. So input 1 pin, we need to make it high, and digital write input 2 pin, we need to make it low. So this will cause the motor to rotate in one direction. Now if you want to run the motor at full speed, you should make the enable pin to high, that is 5 volt. So just for this block of code, let's see if it works. Let's run the simulation from this start simulation button. If there is no error, the motor should rotate. So you can see it's rotating clockwise with a 16,530 RPM. Now if you want to make the motor stop, what you should do, you should make enable 1 pin and enable 2 pin, both of them high or both of them low. So let's make them low for stopping the motor. So this will cause the motor to stop. You can also use the enable pin here. So Whether it is high or low, it doesn't matter. If you are making the both input low, it will automatically stop the motor. So let's observe the effect of stopping motor. We'll run the motor in clockwise. After a delay of 3 seconds, that is 3000 millisecond, it should come to halt, or it should stop rotation. You need to put a delay for the stop condition also. At a stop condition, it should remain for 3 seconds. So let's see if it works. Let's run the simulation. Okay. 3 seconds, it has rotated. 3 seconds, it has stopped. Again, from the very beginning of the code, 3 seconds, it has rotated and it has stopped. So I hope you got the idea how to make motor stop. Now write the code for anti-clockwise rotation. I hope you already guessed it. Digital write and enable pin. You can just leave it as it is. And one more thing, if you are just looking for full speed, you can just put this enable pin at the void setup part. Move it from here. You can just write it here at the void setup. So it will always make the motor to run at full speed. After anti-clockwise direction activation, it should make a delay for 3000 millisecond. So let's see if the program works. Let me summarize once again. First, it will make the motor run for clockwise direction. Then it will make a delay for 3 seconds. After 3 seconds, it will stop the motor. Then it will wait 3 seconds. And again, it will make the motor to rotate anti-clockwise direction. And it will wait for 3 seconds. And after this, it will repeat the whole process again and again. So let's run the simulation. So it's rotating for 3 seconds, stop for 3 seconds, and anti-clockwise rotation for 3 seconds. Then again, it is repeating the cycle. So I hope you got the idea how to work with DC motor direction control. Now let's see if you want to change the speed of this DC motor also. You can do so by just changing this digital write to analog write. Okay. So let's say you want to change the speed of the motor, analog write, enable pin, and here you need to put values between 0 to 255. If you are using 255, you will see it is rotating at the full speed. Now, if you make this half of the 255, that is something like 127.5. So let's run the simulation. You will see the speed will be almost half of the previous full speed. Okay. So this way you can also change the speed of the DC motor. If you want to make it 1/4 of the full speed, just divide it by 4. So it will make the motor run at 1/4 of the full speed. So you see, using this enable pin, we can control the speed. Using the input 1 and input 2 pin, we can change the direction. So that's how we can program for DC motor speed control and direction control. I hope you got the idea how to work with DC motor, how to work with L29 3D IC, and how to program for this type of application. So that's all for this video. I'll see you in the next video. Thank you.